Hi everyone. We previously used tables to record independent and dependent variables. This has its limitations though. To see a more complete picture of a relationship, we can plot the possible values on a graph or a Cartesian plane. This lesson we're going to look at graphing linear relationships. From your prior studies you might recall the Cartesian plane. You start by drawing up the axes. The x-axis runs horizontally and the y-axis runs vertically. The top right quadrant is referred to as quadrant 1. Top left, quadrant 2, bottom left, quadrant 3, bottom right, quadrant 4. The center is referred to as the origin. You always graph a point starting from the origin. You plot the points on the graph by first finding the x-coordinate and then by finding the y-coordinate. Points are written in the form open bracket x, comma, y, close bracket. Let's quickly plot a point 2 just 3, or x coordinate 2, y coordinate 3. First of all, you move 2 coordinates to the right on the x-axis because 2 is positive, so you move in the positive direction. Then you move 3 coordinates up the y-axis because 3 is positive. And that's your point plotted. Remember that the x-axis usually represents the independent variable and the y-axis usually represents the dependent variable. Now we've plotted the point. In order to graph a line, we need to know 2 bits of information. We either need to know a point on the line and the slope, or we need to know 2 points on the line. Here I've got the table from our taxi example where it was $5 entry and $2 per kilometre. On the left you'll see the table that we used, but on the right you'll see a graph of the cost of the taxi, the total cost. You'll notice that we can extract data from the chart that we couldn't from the table. You'll notice that we might be able to say what is 3.5 kilometres travelled, how much is that going to cost? From the chart, we can tell that that costs about $12. We wouldn't have been able to easily pull that from the table. And if the example was more complicated, it'd be far easier to use a chart than it would be to use a table. The gradient of a line is a measure of its steepness, sometimes referred to as the slope. The gradient of a line passing through x1, y1 and x2, y2 is the y step over the x step. That is y2 take y1 over x2 take x1. Another common way to describe this is rise over run. Alright, so let's go through an example. I've drawn a line here. In order to calculate the gradient, we need to identify 2 points on the line. So I've identified a point here, is x1, y1. And I've identified another point there on the line, is x2, y3. Now we can use our gradient or slope formula at the rise over the run to work out what the slope of this line is. You'll notice that the slope is 2. What this means is that the line rises 2 units for every up that y-axis for every unit it runs along the x-axis. The y-intercept of a line is simply where the line intercepts the y-axis. Again, I've got our taxi cost example here. I think we can work out the gradient of this line because we know a lot of points along it. So here I've picked out point 0 and 5, which also happens to be the y-intercept, and point 1 and 7. So the gradient is calculated by 7 take 5, which is y2 take y1 over x2 take x1. And the slope again here is 2. This happens because every kilometre travelled resulted in a cost increase of $2. Again, like I said, the y-intercept here is 5. Thank you.